Hello everyone, welcome to my channel Chemistry is Fun. Today we will be dealing with a topic which I have already started, that is chemical bonding, and today we will be dealing with ionic bond, that is a type of chemical bonding. Before we go to ionic bond, let us understand about the electronic theory of valency. Now see, in any atom, the electrons which are present in the outermost shell, that is the valence shell, they are responsible for the bond formation and they are known as valence electrons. For example, in case of sodium, whose atomic number is 11, the electronic configuration is 2, 8, 1. This single electron which is present in the valence shell will be participating when bond formation takes place. So it is having one valence electron. And as we have seen earlier, the basic purpose why the atoms undergo chemical bonding is to attain stable octet configuration, that is stable noble gas configuration. So if the sodium can achieve up to 2,8 by getting rid of this single electron in the last shell, it can attain noble gas configuration. So somehow it will try to remove this electron. In the process, we will see further afterwards that when it removes this electron, it will become a cation. That is, sodium will become Na plus by removing this electron. Why it is able to do this is because sodium is electropositive. It can easily lose the electron and become cation. So here what we have to emphasize in the electronic theory of valency is that the electrons which are present in the outermost shell, they only will help in bonding, that is bond formation. So overall, electrons are the key factors that are responsible for chemical combinations. This theory was given by Kossel and Lewis, and it was further explained by Langmuir. This theory is explained on the basis of some important points. The first point stresses that for every atom, the valency will depend upon how many electrons are there in the valence shell, that is the outermost shell. In case of noble gases, as we already know, there are 8 electrons in the outermost shell. So they are stable, they are chemically inert. They will not like to participate in any chemical combination. But the atoms which have less than 8 electrons in their outermost shell will be chemically active. They will have the tendency to achieve 8 electrons in their outermost shell. Only some exceptions are there. Hydrogen, it will try to achieve helium configuration, that is, it will try to complete its duplet. 2 electrons, 1s2, it will try to become 1s2 like helium. Because it is having the first shell only, it has only s orbital. The maximum capacity of s orbital is 2 electrons. So hydrogen will try to achieve 1s2. And if it does so, it will become stable. So this is an exceptional case. And as you know, helium is also a noble gas. It is the first noble gas actually. The atoms can acquire noble gas configuration in their outermost energy level by either losing electrons or accepting electrons, or in some cases by sharing of electrons. Electron sharing is seen when covalent bonding takes place. Now the case of losing electron, I just have shown why when the Na plus sodium ion formation takes place. Electron negative atoms like chlorine, they can accept electrons and form negative ions, which are also called as anions. So chlorine, when it takes up one electron, it also gets its octet completed. and thus become stable. Now, as per the electronic theory of valency, when two or more elements combine by redistributing their electrons in the outer shells, and this they do either by transferring electrons or by sharing their electrons. Why they do so? They do so that the atoms can get stable noble gas configuration. The stable noble gas configuration entitles minimum energy state. Minimum energy state means maximum stability. So this is the dream for every atom, to gain this minimum energy state. And this process by which the atoms are trying to gain inert gas configuration by redistributing their electrons, by gaining or losing or sharing the electrons, is electronic theory of valency. Now we stress upon our main topic today, electrovalent or ionic bond. Whenever two or more atoms are forming the chemical bond by transferring one or more than one electrons from the electropositive to the electronegative atom, we call it as a electrovalent bond. Actually, the electropositive atoms like sodium, they lose the electron to form cation like Na+, whereas electronegative atoms like chlorine, they gain the electron and form chloride ion. This is anion. And there will be an electrostatic force of attraction between the cation and the anion, thus leading to electrovalent bond. This is also called ionic or polar bond. We call it ionic because it is based on ions, and polarity will be developing here, so it is a polar bond. It's ionic or a polar bond. Now, when the electron transfer takes place, cations and anions are formed. Cations are positive, as in case of sodium, anions are negative. And there will be an electrostatic attraction developing between the two oppositely charged ions. So the bond formed in this way can be termed as ionic bond. In presence of magnesium, in this case magnesium and chlorine also, magnesium will lose 2 electrons. It will form Mg2+. These 2 electrons will be taken by 2 chlorine atoms to form 2 chloride anions. This Mg2+ and these 2 chloride anions will have this electrostatic force of attraction between them to form MgCl2, magnesium chloride. So here we see that the magnesium is losing 2 electrons. Sodium loses 1 electron, magnesium is losing 2 electrons. Because it is having 2 electrons in its valence shell, it has the capability to lose both the electrons. It forms Mg2+. That will be gained by chlorine, 2 separate atoms, 2 different atoms of chlorine. So we get 2 chloride anions, and because of the electrostatic force of attraction, we find the formation of MgCl2, magnesium chloride. So this is another example of ionic bond formation. Especially we see that the alkali metals, that is the sodium group, lithium, sodium, potassium, they are all electropositive. They can lose electrons. As well as alkaline earth metals like magnesium, just we have seen, they also lose electrons to form cations. The non-metals usually are electronegative like chlorine, fluorine. They will gain the electrons to form anions. So this is the basic thing we have seen today for the formation of ionic bond. I hope you could understand the topic. Thanks for watching. Please subscribe to my channel, as I will be frequently uploading videos in a systematic manner. So kindly subscribe to my channel. Thanks for watching. Thank you.